Well, um, hello everyone. Thank you so much for joining this second session. What we're going to talk about now is how we can use the packet captures to understand how we can see common scenarios related to site-to-site VPNs. We're going to take a look at retransmissions, one-way traffic, fragmentation, and simultaneous negotiations. So can you guys hear me okay?
Loud and clear.
Oh, thank you so much. All right. So as a previous recap, what we checked yesterday, I'm sorry, the previous session was first of all how we can configure the packet capture on an iOS router device, how we can enable it, how we can manage it, and most importantly, what are the parameters and information that we need to take a look into when we're talking about site-to-site tunnel negotiations and traffic encrypted and passing through. So we're going to use all this information in this new session, and you will see now how the potential for this on a site-to-site troubleshooting. All right, so let's begin with the first one, which is retransmissions. So a little bit of information about what retransmissions are. It's when a site-to-site tunnel tries to be initiated, but it fails. And it could be because the packets might possibly get dropped in between or by the remote peer, so the negotiation is not completed. It can happen either on phase one or phase two. It doesn't matter at what part of the negotiation. And the most important behavior here is that if there is no response from the other end, the remote peer tries to send another packet to verify if the remote router is capable to answer back. And it will send a total of 5 packets. And if there is no response for any of those, then the device will delete this session attempt and it will try a new one. So the thing here also that I need to clarify is that this is this whole scenario that I'm going to present is a normal side-to-side VPN on iOS XE routers. And also here is that I'm just going to present one of many possibilities about how this issue could happen. So this is just, again, how to show you how the tools, Packet Tracer, can help us determine where the issue might be coming from. So taking this information right now, let's go straight to the lab because that's the funny part here. We'll go to our lab. And here we're going to use the same topology as before. So here, as a quick example, let me just go back here. If we take a look right now at our tunnel session, show crypto IPsec SA, we can see that we do not have the tunnel established. How do I know that? Because here we don't have inbound and outbound essays. This is a value that is very important that it's established once the tunnel negotiation is completed. But as you can see here, I'm not seeing it. And if I take a look at the other end, it's going to be a similar behavior. Show crypto IPsec SA. And also we are missing those parameters. So what we're going to do now here is that we will collect a few captures and verify what's going on. So here, give me 1 second. As before, as we clarified in our previous session, we're going to first determine the access list to use for the captures and then enable the capture using that access list. So first of all, let's go and use our capture. So we're going to, so since we're troubleshooting the tunnel negotiation, we're going to just filter the UDP packets between this peer and the remote end. And that's going to be the same on this side. Let's use it. And now that we have the access list, let's create a packet capture. Monitor, capture cap, access list, the same name. Buffer size 10. Interface, gigabit Ethernet 1, both ways. That's very important. And we'll do the same here. Monitor capture cap, access list cap. buffer size 10 megabits, interface gigabit Ethernet 1, both. So now the captures are enabled. Let's start them. Monitor capture cap start and monitor capture cap start. So here up to this moment, we do not know why they both peers are not able to complete the negotiation. So if we take a look at a quick review of what is currently collected in the capture, it will be show monitor capture cap buffer brief. Okay, we can see here that on this end, something is being sent to the remote peer. However, we're going to take a look at this in a moment. And well, as I told you before, what we're troubleshooting right now, it's an iOS XC devices, because on SD-WAN tunnels, it's a little bit more different because that's a straight IPsec, but for a normal IPsec tunnel, it's an IPsec negotiation. So here, let's take a look at this remote end, show monitor capture cap buffer brief. So here we have another type of behavior. So we can see that the remote end is also sending packets, but something is happening. But as I told you, this is just a quick review of what seems to happen. But I'm going to take a look a little bit further now that I have the captures. But something that I need to clarify with you guys right now, it's the following. Before we take a look at the captures, is this. Perspective matters. So these are the same captures that I took, but this is a few moments later, 10 minutes later. And as you can see, at some point, one end is sending more packets than the other. So it looks like something in between is blocking those captures. I'm sorry, that is blocking that traffic. So if we take a look now at these retransmissions, I already have the captures. Let me just give me a moment. Here, if we take a look at this side, we can see that the device is sending something. This is the router A for clarifications. So if we use the same information as we just understood what we need to look into the captures, we need to take a look at the ports, the source and destination addresses, and then the initiator SPI. So here we can see that the router A is trying to send something. Here we can see that it is a packet to initiate the tunnel. But if we take a look at the other packet, this is a different negotiation. Can you see this? The value is totally different, and it only has the initiator SPI, and also it has the rule of initiator request. So this is telling us that both ends at this moment are trying to send to initiate the tunnel. But if we take a look at the second capture, I'm sorry, the third one, we can see that the router A, it's actually responding to this negotiation, and it says the values that are missing due to the protocol that explains who is populating the initiator and responder SPI. So here we can see that at some point it looks like one of the negotiations is completed, but take a look at the next packet. So here it looks similar to the first one, but it's another attempt. So this is telling us that something in between is blocking the traffic from one perspective, from router A to router B, but the negotiation from router B to router A is it's passing with no problem. So if we take a look at the other capture that I have here, this one, this is a capture on the router B. This is a different behavior. So if we take a look again at the same values, we have that the router B is trying to send something. If we go to the next one, the value totally changes because this is a new attempt. So here you can see that on this part, we are never receiving the responses from the remote router A. So in this case, what's happening, guys, so I don't keep you excited, is that I just did that the remote the internet router that is doing that is behaving as an ISP is the one blocking the traffic just one direction. So that's the reason why we're seeing this behavior on those captures, and we can at least clarify that the issue is not happening in the routers; it's actually something in between. So since I already know what's happening, I can't remove that command that it is blocking it is an access list in between. So if I go here on this internet router interface gigabit, I'm sorry, conf interface gigabit Ethernet 1, no IP access group block in, we will see in a moment that the tunnel negotiation will happen. So this is because the capture has been active and it's been capturing all the information. And take a look here. Since we just removed that part on the internet router that was blocking the traffic, the tunnel is already up. So if we take a look here, show crypto IPsec SA, now we have these values populated. So this is simulating a common scenario from the VPN team, which is the ISP blocking the traffic to initiate the tunnel. As I told you, it could be something in between, or it could be the remote end not responding to those packets, or the packets being blocked by the remote router B as well. So it's just one of many possibilities. All right. So after we just explain what to look for in these type of scenarios, as a quick review is that we need to take a look at the sessions that are being negotiated, who is the initiator, who is the responder, and since this is a interaction between two devices, we need to take a look at the same, the expected behavior is to see the same values on both ends. But as you saw here, the values were totally different on both ends. The amount of packets and the SPI's values, and also the rules for each capture. So as I told you, perspective matters. So now we can take a look at the next scenario. Give me one moment here. One-way traffic. So after the tunnel is up, then we can have another scenario in which we're sending interesting traffic through the tunnel from our local resources to the remote resources. And it could possibly happen that we send the packets over the VPN, but then there is no response back. But the question here would be where the packets are being blocked. Is it going to be the same scenario as in between the ASP blocking the traffic, or the device, the remote peer blocking the traffic, or simply the remote and the destination is not responding? That's something that we can also clarify on this scenario with packet captures. So we're going to do the same here in our lab. I'm going to go back here. So now that the tunnel is up, I'm going to try to ping for it, so I can give you the example, guys. So I have a resource on the other end, 10.2.2.2, source, loopback 0. And as you can see here, I'm sending something, but I am not receiving any response. So before we saw that the internet router was dropping some traffic, but I believe that that's not the same issue right now. So we're going to adjust our access list for the packet tracer, and we're going to see how, in which part this is not working. So give me one moment. Uh, uh, um, we are going to, as I told you, we're going to adjust the access list. Instead of now that this is interesting traffic, instead of UDP packets, we're going to catch only ESP, which is the interesting traffic encrypted already. So let's modify the access lists. So now it's ESP. Monitor capture cap stop. No monitor capture cap. So no monitor capture. Okay, it's already disabled. Perfect. And also on the other end here. Oh, and also, I'm not sure if you guys remember why I need to delete the packet capture and modify the access list is because, well, from my experience, every time that I have a capture enabled, but then I'm trying to adjust the access list, those changes do not seem to apply to the packet capture. So it is always best to remove the capture and put it again, and then so you can for sure know that the changes will be applied. because I have a lot of issues with that. Okay, so we are adjusted here. So monitor capture, cap, access list cap, interface gigabit Ethernet 1, both, monitor capture cap, start, and the same here. Monitor capture cap start. So since now we're troubleshooting interesting traffic, we're going to do the ping one more time since we are just uh, getting the captures ready. And let's take a look at how we'll see this on the captures. All right, so it's still not working. Okay, so up to this point, this side A router is trying to send something, well, the ping over the VPN, and we can see that it's just one direction. So we take a look at the remote end, just this quick review perspective. Show monitor capture cap buffer brief. This is interesting because on the VPN is up to this point we can discard the problem coming from the VPN or something related to connectivity in between because we are receiving those packets. But for some reason, this resource that I'm trying to ping is not answering back. So I already also have this capture. So give me one moment and I'm going to show you what is actually happening here. If we extract these values and see what's going on inside them. Okay, put him here. So this is the side A. And as you can see right now, it's technically the same behavior. But something that we can confirm is an important thing is verify if we are sending the complete packets. So here we can see that we're sending, but we are not receiving any response back. So if we go now to the capture on side B, we are seeing that that protocol actually is arriving here as well, but we're not seeing any responses. Oh, sorry. This is just one thing. Here, this is the ESP. I'm going to clarify this in a moment. So if we take a look here, we're seeing the same packet capture, the same ESP sequence number, but we are not receiving the response for each packet. So we can, as I told you, we can clarify that the problem is not the VPN, but it's something on the resource that we're trying to reach. So here, the reason why I'm specifying this and why we're getting like the clear text is because for some reason the device, the router captures the packet, but at the same time it decrypts it. This is not a common behavior, but I've seen this happening many times. So I just want to clarify that because it's something that you guys might get into it when you are troubleshooting. So the thing here and the reason why this is happening is because on this side, the interface that I'm trying to reach is disabled. It's a, I manually put it down. So if we put it back up, comfy interface, look back 0, no shut. And if I do the ping one more time, it's working. So the reason why I'm giving you this type of scenarios is, as I said before, I cannot cover in this session all the possible reasons for these two retransmissions and Wi-Fi traffic to happen. But I can give you the meaningful scenarios that are the most common and how we can clarify where the problem is coming from. So we just cover a scenario where the issue is on the VPN, traffic in between being blocked, or when the issue is out of the VPN, when the resources are not responding. But well, between these two, the retransmissions and Wi-Fi traffic, it can happen the same way on both. So it's always best to understand how this is happening. And then we can now move back to pre-fragmentation. This is an interesting one. So a little bit of review. When we're sending packets over a VPN, what happens is the encryption and the hashing, it adds more payload into the packet. So when we're getting, for example, if we are reaching, if we're having a packet that is almost the same size as the MTU configured in the router, then what's going to happen is that the device is going to fragment the packets because it's too much. So by default, the routers have something called prefragmentation packets. That means that when we are almost reaching the maximum size of the MTU, the device is not going to encrypt the packet and then fragment it later, because that creates a lot of issues. What's going to happen is that the packet will be fragmented first, so it can be smaller. Then the encryption part will be added, but still it will be small, and then it will be sent over the tunnel. This is because we can decrease the overload in the next device due to unencrypted processes, and because then if a packet is missed in between, there will not be any problems waiting to unencrypt a packet that it didn't arrive. So in that case, this is just a quick scenario, but I'm going to show you how this is seen. So here in my lab, one more time, I have everything ready, but on this internet router on the interface 2, let's take a look. Uh, 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 Show run interface tunnel. I'm sorry, gigabit Ethernet 2. Here, what I'm doing is that I'm setting an MTU that is a little bit smaller than the default one. So what's going to happen is that if I do a ping, for example, it works. But then if I do a size a little bit bigger, for example, here is going to be something of 120. It's a little bit bigger. So we can see that it works, but we're not seeing how the packets are being sent from one side to the other. So let's clear the captures and see the differences. Monitor capture cap clear. Okay. Monitor capture cap clear. Oops. So if I do the ping one more time with a bigger size, and if we take a look at the captures, capture cap buffer brief. We can see that on this side, we are not getting any problems because it's one packet sent, received, sent, received. So that looks pretty good. But if we take a look at the other end, we can see that it's a little bit bigger, the amount of packets that we receive. So technically, what is happening here is that this device, the internet, is fragmented the packets because they are too big for the interface, gigabit 2. And that's the reason why we're seeing a few packets more, because those are fragmented. So in this case, it's not a problem. It's a scenario that might happen, but in a real troubleshooting scenario, it could be that we are fragmenting the packets, but some of them are not arriving. But it's good to know how this can be seen. So I'm going to show you guys also the packet captures for this. Now that we can extract them, fragmentation, side A and side B. So here on the side A, as expected, we are not seeing anything out of the ordinary. So we're sending the pings and we're sending the responses. That's just fine. But if we take a look at the other end here, we can see this, which is more important. We are seeing some packets that are fragmented. And then we see another packets that are coming with the ESP. So here, the most important part is take a look at the information of the packets. So for example, here on this fragmented packet, we can see in the flags that, well, the information is telling us that it's fragmented, but if we don't have this notification, then we can take a look at the flags of more fragments and it's set to 1. This is telling us that this is not one packet, there are more to come. So this is just warning that this packet is telling us like, okay, the next packet is going to be an additional from this one. So if we go to the next one, we can see that this value changed to 0. This is telling us that it's no longer waiting for more fragmented packets. So this is telling us that the fragmentation ends with this packet. So when the remote end receives that packet, it can put it back together and then send a response back. And another thing that is very important to take a look into is also the perspective is very important on these fragmentation scenarios, because we will see who is actually the packets that are being affected for the fragmentation. So this is not a scenario that is going to affect you if the connectivity is good in between, but it can happen that some packets might get lost due to, I don't know, connectivity issues, access lists, or the packets being too big that the device cannot handle them. So this is a correct way or a good way to take a look into this. So I think I saw one question here. Give me one moment, guys. Is there an interface on site where you could apply the capture that will show fragmentation? The answer is for that question, Roger. The answer is no, because the fragmentation is not happening on these two sides. The fragmentation is happening on this side. But for example, if I do the same and try to modify the side A gigabit 1 MTU, then the fragmentation would immediately happen on this side. So the purpose of this topology is to explain to you and separate the scenarios, but it can also happen on side A. So you can have that scenario a little bit earlier. But yeah, so you can, but at this moment, it's not the purpose for the topology. So after we can clarify this, we can now go to the following and last scenario, which is the simultaneous negotiations. So since this type of VPNs that we're talking about are road-based VPNs, which means that they are coming from a BTI, there is no way to trigger the tunnel because the router itself will trigger the tunnel immediately. So this is so when you configure the tunnel on both ends, then both devices will try to initiate the tunnel at the same time. There is no way to say like, okay, hold on, I'm going to be the initiator. Well, it can be, but that's something related to IPsec configuration that you can put a responder only. But if you do not do that, then both devices will initiate the tunnel at the same time. So this is also a common scenario. It cannot be a problem. It could be a problem if both devices do not agree on the negotiation. But it's interesting to understand which tunnel and which session was actually the one that won, for example. So in this case, I also have these captures. Is going to be a little bit faster. Give me 1 second to show you how this will look like. Here and here. So here on these captures, we can take a look at this one that is the site A. So for example, on this negotiation, we can see if we expand these values that the site A is trying to send a negotiation request. And then we are getting a response for that negotiation from the remote end. So it looks like this first negotiation won, and it's going to be continued as we take a look at the other captures. So up to this point, we're getting now to phase 2 with this negotiation, and then the last packet it's also sent. So we might assume that this negotiation is already established, but if we take a look at the next capture, take a look here. This is awesome. The remote end is now trying to initiate another tunnel, even though that we just created this one. And so the remote end is now acting as the initiator. It's sending the very first packet without the responder SPI. So that's a value that remote A is going to populate, and it does. We are sending the response back, and we are getting actually two negotiations here from packet number 1 up to packet number 10. So if we take a look at the packets, the next packets is going to tell us which of these two sessions are actually the one that took over and won. So we take a look at the SPIs 6FF and 013. That refers to the second negotiation. So in this case, that's the negotiation that both ends will keep up, and the first one is going to be removed because um, this is not longer needed. Again, this is not an issue if at the very end the traffic is being sent using just one SPI, but it could be possible that in a scenario that both ends do not agree, so they can continue negotiating, and then you will get a lot of packets on the captures and also on the debugging. And or also you can have a scenario that you have two already created, but then the packets might be sent through one VPN and then to receive the responses to another. So it's just to show you how we can analyze the final decision of the routers if everything is working just fine. So up to this point, guys, we just covered everything. I went to the demonstration back and forth because that was the purpose for this second session, to have a more uh, visual lab representation. So I would like to know at this moment from you guys if you have any questions. I'm all ears. No questions, guys?
Nothing at this time.
Alrighty. So in that case, I believe we can end the session at this moment. So as a quick recap, the packet captures are not just for VPNs, it's for troubleshooting traffic or on devices. But you can see here that we can have a huge advantage using packet captures for VPN troubleshooting. So it's good to understand what we need to look into and how a common scenario should be seen versus what a problem is seen. So I hope that these two sessions, guys, were helpful for you. And if you had any questions in the future, you can ping me or any VPN engineer, and they will be able to assist you and clarify your questions for VPNs or packet captures. So in that case, again, guys, thank you so much and have a nice day.
Thanks to you, Angel. Have a
Thank you.
Thank you, guys.
Thanks, Angel, for your time. Thank you.